All right, now we'll move on to the y-intercepts. And just like our graph, it's actually a little bit easier once you know what to look for, but it's a little bit less obvious if you're not sure what to look for yet. So one thing we need to think about with our y-intercept is what are we looking for? Well, if we just think about a graph real quick, this is just a quick side note. If we think about any graph, right, and this is our, oops, this is our x over here, and then this is our y. And we always know that zero is right here, right? Zero is always right there. Well, anytime I have a line, if we're looking for where it crosses the y-axis, what x value does it line up to? 0, right? If it crosses here, what x value did it line up to? 0. If it crosses here, what x value does it line up to? 0. What if it crosses here? What x value does that line up to? 0. So that's the important thing here, is that we're always looking for where x equals 0. So we're always looking for where x equals 0. Okay, so that's the thing to think here. Well, let's look for our x's, and we'll look for where x equals 0. And I see that happens right here. That means that this right here, the y, because it's the y-intercept, so it's where x is 0, what's the y value? That is the y-intercept. So in this case, our b equals 0. Okay, so we have our b equals 0. We have our m equals 150. We're going to, again, go back and put these together into our equation, y equals mx plus b. See if you can write that equation. What would it actually look like once you put them all together? Good job. We have y equals 150x plus 0. And you could write this very simply as y equals 150x. Either of these answers I would accept. See if you can do that for your example.